Greetings to everyone. I am Kushi Gulwani, a diploma student from the Alpag Educational Institute, and this is my presentation for the subject Fundamentals of Information Security. And my topic is Applications of Cryptography in Securing Communication. First, we will take a look on the contents of the PPT. So, starting from what is cryptography, roles of cryptography in securing communication, importance of cryptography in securing communication, key concept of cryptography, techniques of cryptography, applications of cryptography in securing communication in government and military, and in online banking and financial transactions, and how blockchain and cryptography are related, and the challenges of cryptography in securing communication. So, starting from what is cryptography? The science of protecting information by transforming it into an unreadable format only reversible by authorized parties. This means a technique or a process that encrypts and decrypts the message so the cyber attackers or hackers cannot perform any cyber crimes. The goal of cryptography is to ensure data confidentiality, integrity, authentication, and non repudiation. Let's understand by the heading Roles of Cryptography in Securing Communication. Integrity. Integrity means that the accuracy of data or the message should be the same and the message should be accurate. Second, authentication. Authentication confirms the ID of the sender and the receiver too by digital signatures and certificates. Non repudiation, it prevents the sender from denying the message they sent. It means the sender is requested to not send the message. Confidentiality means only authorized party can read or send the message, and unauthorized parties cannot read or send the message via encryption and decryption. Access control. Access control refers to control who can access by key management and permissions. Now, this diagram explains cryptography. The sender sends a plain text data. A shared key encrypts the data into ciphertext. The ciphertext is converted by decryption data key, that is a shared key, into decrypted plain text, and the receiver or recipient received the text or the data. Now, next is importance of cryptography in securing communication. What is the need of cryptography in securing communication? Protects privacy. It ensures that the sensitive information or personal data of a sender or receiver is protected and is not shared. Second, ensures authentication. It ensures the identity of the parties that are involved in the communication. Third, supports trust. It builds trust between the user by ensuring that messages are stored between them and is not shared or hacked by any cyber attacker. Fourth, enables secure transaction. Facilities like online activities, including e-commerce, it builds confidentiality and enables secure transaction. Prevents data tampering. It prevents by verifying that data has not been altered, means data is maintaining its reliability and integrity. Supports regulatory compliance. It supports organization to meet legal and regulatory requirements like GDPR and HIPAA. Next, enable digital signatures. Digital signatures are used to ensure that the sender and receiver are authorized users. It is the foundation for modern systems like VPNs, blockchain, secure emails, and digital certificates. Now, what are the key concepts of cryptography? Following are the key concepts of the cryptography: encryption, keys, symmetric encryption, asymmetric encryption, hashing, digital signature, PKI, that is public key infrastructure, decryption, MAC, that is message authentication code. So, what is encryption? Encryption means converting a plain text into unreadable ciphertext. Whenever a sender sends the data, it is converted or encrypted to ciphertext. Keys. Keys are of many types that are secret, private, and public. Mostly secret keys are used to encrypt and decrypt data by symmetric and asymmetric encryption. In symmetric encryption, same key is used for both encryption and decryption. And in asymmetric encryption, different keys are used for encryption and decryption. For encryption, a public key is used, and for decryption, a private key is used. Next, hashing. It converts the data into a hash for integrity. A hash is a fixed length value. Now, digital signatures. Digital signatures are used to verify the authentication of the message or the sender or the receiver. PKI. PKI stands for Public Key Infrastructure. It is a system for managing digital keys and certificates. Next is decryption. It is the process of converting ciphertext back to the readable plaintext that is to be received by the receiver. Last one is MAC, that stands for Message Authentication Code. It ensures that the message has its own integrity and authenticity by generating a checksum. Now we will discuss the techniques of cryptography. The techniques of cryptography used in securing communication. First is symmetric key cryptography. It uses the same key for encryption and decryption, for example, AES and DES. Second is hash functions. Hash functions converts the data into hash. Hash is a fixed value that is used for data integrity. The examples of hash functions are SHA-256 and MD5. Digital signature. As we have already discussed, RSA and DSA are some of the example of digital signatures. It provides authentication and integrity by signing in with a private key. ECC, elliptic curve cryptography. It is a form of asymmetric encryption, but it is done with smaller keys and faster performance. Next is hybrid crypto systems. Protocol like TLS and SSL are hybrid crypto systems. It is a combination of symmetric and asymmetric techniques for efficient encryption. Next is homomorphic encryption. It allows computations on encrypted data without decrypting it. The last is asymmetric key cryptography. It uses a pair of keys, public and private. Public one is used for encryption and private is used for decryption. The examples are ECC and RS. Now this is a diagram that describes different techniques. Symmetric, asymmetric and hybrid. Asymmetric is divided into three further classification, that is RSA based, ECC based and pairing based. RSA based is a tiny PK. It is an example of RSA based. Tiny ECC is an example of ECC based techniques. Tiny PBC, nano PBC and tiny pairing are examples of pairing based techniques. SPINS, LEAP and TinySec are examples of symmetric cryptographic techniques. SCUR, MASA and CFleek are examples of hybrid cryptographic techniques. Now, applications of cryptography in securing communication. SSL and TSL. These are some of the protocol in HTTPS connection that ensures privacy, integrity and secures the web traffic. Second is email encryption. It protects the contents of the email. For example, PGP. VPNs. VPNs are virtual private networks. It encrypts internet traffic to secure communication over public networks. Next is securing messaging. It encrypts the message to ensure privacy. For example, WhatsApp. WhatsApp uses end-to-end encryption to secure messaging between two users or more than two users. Digital signatures. It verifies the authenticity of emails, contracts, and documents. Banking and financial transaction. It ensures secure payment and data protection or the sensitive data protection of the user. Cryptocurrencies. Cryptocurrencies are currencies of cryptography that is used for secure transaction and manage digital currencies. For example, Bitcoin. Bitcoin is a cryptocurrency. Authentication. It provides secure login and access control by method like 2FA, that stands for two-factor authentication. Secure file sharing. It protects the data that is being transmitted or shared by encrypted cloud storage and file sharing apps. Now this diagram describes the secure communication protocols. HTTPS. The S stands for Secure Hypertext Transfer Protocol. Second is SSL, that is Secure Socket Layer, and the Transport Layer Security. Next is VPN, Virtual Private Network. Next is IPsec, that stands for Internet Protocol Security. The next is SSH, that is Secure Shell. The last is Kerberos. Now we will discuss the applications of cryptography in government and military. It secures the voting system by ensuring the privacy of electronic voting machines and the integrity of the data. It provides secure communications by ensuring the confidentiality and integrity of sensitive data of government and military communication. Encryption of classified data. It protects top secret and sensitive data from unauthorized access. Identity verification. It identifies the authentication of government employees, military persons, and contractors by smart cards and biometric processes. Military operation. It secures communication channel during military operations to prevent interception by outsiders or adversaries. Next is digital signatures. By digital signature, we can secure or authenticate the document, contracts, and treaties. Secure military network. It protects the military internets and network from cyber attacks and cyber crimes. Encryption of GPS signal. It ensures the security of GPS data used by military assets for navigation and positioning. Weapon system security. It secures control system for weapons like drones, missile, and other military technologies to prevent hacking and unauthorized control. Now next is applications of cryptography in online banking and financial transactions. First, it is secures online payments, that is by credit card or debit card data encryption. Authentication. It verifies the user by methods like biometric and 2FA, that is two-factor authentication. It also authenticates by digital signature to ensure the authenticity of financial documents and contracts. It ensures transaction integrity by MAC or message authentication code address. It ensures security of banking apps by safeguarding mobile banking apps from hacking and unauthorized access. It ensures cryptocurrencies to secure digital currencies and blockchain technology. For example, Bitcoin. Tokenization. It replaces the sensitive payment information with a unique identifier to protect card details in payment processing. For example, when we enter a PIN by using a UPI or online payment method, it is replaced by dots or stars or any other character to replace the sensitive data or the sensitive information of a user. Secure wallets. It protects digital wallets by encrypting keys used to access cryptocurrencies or sensitive financial data. For example, using pins, password, passcodes, or other identification methods. Data encryption. It protects sensitive financial data such as account numbers and personal details during transmission over the internet. It is done by protocols like SSL and TLS. Now we will discuss how blockchain and cryptography are connected. First of all, what is blockchain? A decentralized distributed ledger that records transactions across multiple computers, ensuring transparency and security. It is a ledger or a centralized ledger that records transactions in computers but ensuring that it is secure and authenticated. It involves cryptographic hashing. Each block in the blockchain is linked to the previous one using a cryptographic hash which ensures integrity and prevent tampering. It uses public and private keys for secure transactions and encrypting and decrypting the data. It uses digital signatures for verifying the identity of transaction senders and ensures authenticity and non-repudiation. Immutability. It ensures once data. Next is consensus mechanism. Cryptography uses algorithms like proof of work or proof of stake to validate and confirm transactions across the network. Immutability ensures once data is recorded on the blockchain, it cannot be altered without the detection. Security in cryptocurrency. It is used to ensure trustless peer to peer transfer and secure digital currency transactions. Now we will discuss the challenges in cryptography for securing communication. Computational overhead. Cryptographic operations, especially asymmetric encryption, can be intensive and slow down system. Cryptanalysis. As computational power increases, existing cryptographic algorithms may become vulnerable to attacks. Quantum computing, human error, data breaching, side channel attacks, regulatory issues, scalability, and key management. These are the challenges that cryptography may face in securing communication. Maybe the key management is not securely generating or distributing. Maybe the scalability of the network or the efficiency of the network for large volumes becomes challenging. Regulatory issues like government may require legal access to encrypted data, which will potentially weaken the security. Side channel attacks like maybe the attackers might exploit information leaked during encryption process. For example, when a data is being encrypted, some information may be leaked that can be exploited by the attackers. Data breaching is the main risk that can be faced by cryptography or using cryptography. Human error like weak password, insecure practices, and poor key management can undermine cryptographic protections. Now, concluding the slide, the summary of the slide was cryptography plays a critical role in securing communication. However, it doesn't provide 100% security, but it somehow provides or increases the security of communications. The future outlook will evolve to address emerging threats, especially coming from quantum computing. Thank you so much.